This is a video about like terms. If you don't remember what like terms are, let's start by thinking about this collection of apples and bananas on your screen. Now, there are a lot of really delicious things that you can do with both apples and bananas, but when they're all jumbled together like this, before we can actually do anything with them, we need to organize them. And since I'm a math teacher, I want to organize them using mathematical language. So what I'm going to do is use a variable. A variable is just a symbol that stands for something else. So I'm going to use the variable a to stand for apple. And I'm going to use the variable b to stand for banana. And since I have 1, 2, 3, 4, 5, 6, 7, 8 apples, I'm going to write down 8 a's. These 8 a's are called like terms, basically just because they're all a's. They all have the same variable. And I could add them all together to say that I had 8 apples. So maybe I would write 8a. So just to be clear, what I have here is a variable. So that's the a, and that's a symbol that stands for something else. A stands for apple. And now this 8 is called a coefficient. And what that 8 is doing is it's the number in front of the variable, and that's telling us how many there are. There are 8 a's. So now we could do the same thing for the bananas. There are 1, 2, 3, 4, 5, 6 bananas. So I could write down 6b. b is the variable for bananas. 6 is the coefficient in front of us that tells us there are 6 of them. Now, one thing that you have to be careful about is that if I tried to add together my 8 apples plus my 6 bananas, all we could say was that that was 8 apples and 6 bananas. Since they're different, we can't add them together. You can never add together terms that don't have the same variable. However, when you do have an expression that contains a bunch of terms with the same variable, you can combine like terms to simplify the expression. So in this expression, the 7a and the minus 2a and the 9a are like terms because they all have a's in them, while the 3b, the b, and the negative 3b are also like terms because they have b's in them. The green ones match each other, and so do the red. To combine like terms, what we're going to do is add together the coefficients. So we're going to add together the 7, and then anytime you have a minus in front of the term, you want to think of that as sticking to the coefficient. So that's going to be a minus 2, and then a positive 9. So 7 minus 2 is 5, plus 9 is 14. So that means that what we have in total are 14 a's. For the b's, we have a 3, and then there's nothing in front of this b, so that means it's a single b. So that's like it has a coefficient of 1. That's understood to be there. And then this b has a coefficient of negative 3. Remember that minus sign sticks onto the coefficient. So we've got 3 plus 1 is 4, minus 3 is 1. So that's 1b, or you could just write a plain b. And since all of these terms were added together to begin with, we have to remember that 14a is being added to 1b. So our final answer would be 14a plus b. You don't have to put in the 1. And your take-home message here should be that you add the coefficients on like terms to simplify, remembering that that minus sign will always stick to the 3, that minus sign will stick to the 2. Now we'll combine some more like terms. So number 1, I look at 3 and see that it doesn't have any variables with it, so it's just a number. So I'm going to look in the rest of the expression and see if there are any other just numbers. And there are. There's a 6. So those are going to be like terms, one number and another number, no variables. Then in this expression, there's also a negative 4b, but there are no other b's. So for my answer, what I'm going to do is I'm going to add together the 3 and the 6 because they're like terms and say that that's 9. And then I'm going to leave the negative 4b as is. So I have 9 minus 4b. Number 2, I'm going to see 3m. I'm going to look for some other m's, and I'm going to see this minus m. You want the minus to stay with the m. And then I'm going to see a 4n, but there are no other n's, so I'll just underline the 4n as it is. Now I'm going to add the coefficients on like terms. We've got a 3, and then this is really like a minus 1. So 3 minus 1 is going to give me 2. So that's going to be 2m. And then I have a 4n, and that's just going to stay the same, so I'll add that on to the end. In number 3, I see a 7k, but I don't see any other k's. And then I see a 4j, but no other j's. And then I see a -5, but no other regular numbers. That means that there are no like terms to add together, so if someone said to me, combine like terms, I would say there aren't any, and I would just rewrite the problem and say, that's the answer, and we're done. So 2 other takeaway points about what like terms are this. Like terms are terms that have the same variables, but different coefficients. So an example would be 3m and -m. Or like terms can be just numbers only. That's what we see with the 3 and the 6, which we added together to get 9. And you also know that when you have like terms, you can combine them by adding their coefficients.